So, limiting reactants. If reactant quantities are not exact mole ratios, and that's what we've been working with so far, are exact mole ratios. So if they're not exact mole ratios, not all of the reactants are going to be used up in the reaction. One of the reactants will be in excess. The reactant that's not in excess is called the limiting reactant because it's that reactant that's going to limit what can be produced. You must use the limiting reactant number of moles in your calculations. That's really important. It's limiting the reaction. So you need to use the limiting reactant amount in your calculations. So let's have a look at the pancake example. 1 egg plus 1 cup of milk plus 1 cup of flour will make 12 pancakes. There's my egg, there's my cup of milk, there's my cup of flour, and I get 12 pancakes. Yum. What happens if I've got 3 eggs? Now I've got 3 eggs, 1 cup of milk, and 1 cup of flour. How many pancakes can I make? I can still only make 12 pancakes. Why is that? Because I've only got 1 cup of milk and 1 cup of flour. So what I will do is I will just use that 1 egg and I will have 3 eggs left over. The milk and the flour are then said to be the limiting reactants because this is what is limiting the amount of pancakes that can be made. It's not the eggs because I've got 4 eggs available, but only one of those eggs is going to react with 1 cup of milk and 1 cup of flour to make 12 pancakes. So these are classed as the limiting reactants. They limit how much product can be made. The eggs are called the excess reactant. And how many eggs do I have in excess? Well, only 1 gets used in the reaction, so I've got an excess of 3 eggs. And that's as simple as this is, but you need to think about it when it comes to calculations. Now, there's one in your book, in your booklet that I've given you, which is about sandwiches, and it just shows you the same sort of thing. To make 1 sandwich, I need 2 slices of bread, 3 pieces of meat, and 1 slice of cheese. Who has 3 pieces of meat? I'm not quite sure, but if that's what you like, that's fine. So to make 3 sandwiches, we need 6 slices of bread, 12 pieces of meat, and 5 slices of cheese. And that's basically what this is showing you. So if I've got this amount, I've got 6 slices of bread, each sandwich has 3 pieces of lunch meat, so 3 in that one, 3 in that one, 3 in that one, I'm going to have 3 pieces left over. 5 slices of cheese, each one has 1 slice of cheese, so I have 2 pieces of cheese left over. Okay, let's look at this example question because it's always easier to use an example. Excuse me. In the Haber process for the production of ammonia, nitrogen and hydrogen are reacted according to the equation. Nitrogen plus 3 hydrogen make 2 ammonia. If 2 kilograms of nitrogen is reacted with 1 kilogram of hydrogen, part A is asking which reactant is in excess and by how much in terms of mass, and part B is what mass of ammonia is produced. This is a step-by-step calculation. I've tried to simplify this a little bit this time by using a table. I've got a table in your notes that looks something like, I'll just flip forward like that, but I want to go through this step by step. So the first thing I want you to do is have your 2 columns going. So we've got nitrogen and we've got hydrogen, because what we're trying to work out is if 2 kilos of nitrogen reacts with 1 kilo of nitrogen, which reactant is in excess and by and how much in mass. So nitrogen. I know my mole ratio is 1 mole of nitrogen makes 3 mole of hydrogen, and I know that from my chemical reaction. 1 mole of nitrogen will react with 3 moles of hydrogen. So that's my mole ratio. I then work out the number of mole, just like I would in any other equation. 71 moles of nitrogen are made. So I've got 2,000, which is the mass, 2 kilos, divided by 28, which is the molar mass, 2 times 14. And that is proportional there to, oh well, how much hydrogen is being made. I shouldn't really say it's proportional. 1,000, which is the mass in kilos in grams, divided by 2.0, which is 2 times 1, the molar mass. So 500 mole. So that's what we're reacting. That's the information that we've been given. 1 or 2 kilograms of nitrogen equals 71 mole, and 1 kilogram of hydrogen is 500 mole. We need to decide which of these are in excess. So we need to compare how much would be needed of each based on this mole ratio. So if I was to have 71 mole of nitrogen, how much hydrogen would I need to react with that? I need to work out the mole ratio times the 71 mole, and I get 213 mole of hydrogen. We just worked out 500 mole of hydrogen to play with. So therefore, it is less than that 500 mole. So I've got enough hydrogen here. So this reaction can go ahead, 71 mole of nitrogen with 213 mole of hydrogen. Let's look the other way. If I've got 500 mole of hydrogen, which is what the question's telling me I've got, how many mole of nitrogen am I going to need? So it's mole ratio times 500, and that equals 166.7 mole. So for every 500 mole of nitrogen, of hydrogen, I'm going to need 166.7 mole of nitrogen. Do I have 166 mole of nitrogen? No, I don't. I only have 71 mole of nitrogen because I've only got 2 kilos of nitrogen. So this is more than 71 mole. So this reaction cannot happen. And this is the reaction here which will happen. This means that the nitrogen is our limiting reagent, and it's 71 moles of nitrogen. And our hydrogen is the excess reagent. How much is it in excess by? Well, I start off with 500 mole, and to react with 71 mole of nitrogen, 213 mole will be needed. So thus, 500 minus 213 equals 287 mole that just sits there and does not react. This is how much hydrogen is in excess. Now remember, when you work out any further calculations, it's this amount in mole of the limiting reagent, because just like the eggs with the pancakes, or sorry, not the eggs, the flour and the milk, this will limit how much can be made, the limiting reagent. So that's your table that I've given you in your notes, so hopefully that makes a bit of sense now. So the first bit of the question is asking you which reactant is in excess and by how much in terms of mass. So we've worked out that nitrogen is the limiting reagent and that hydrogen is the excess, and this is how much excess hydrogen we had. So the mass of hydrogen remaining will equal the number of mole times the molar mass, which equals 287 mole times 2.0, which equals 600 grams. So 0.6 kilograms of hydrogen will remain left over. The second part of the question is asking you what mass of ammonia is produced. So from the table, we know that the number of moles of nitrogen reacting was 71 moles, and that's our limiting reagent. We need to use the limiting reagent when we're working out the product. So we can see that the mole ratio of nitrogen is 1 to the mole ratio of ammonia, which is 2. So it's a 1 to 2 ratio. So it's 71 mole of nitrogen will make 2 divided by 1, which is the mole ratio. Remember, unknown divided by known, times 71. So the number of mole of ammonia equals 142 mole. All we have to do is convert that into mass, because remember, that's what the question's asking us for. So the mass of ammonia equals number of mole times molar mass, which equals 142 mole, which we just worked out, times 17 grams per mole, which equals 2,400 grams or 2.4 kilograms of ammonia. Okay, if you're feeling confident, have a go at this question, which is question 11 on page 16 in your booklet. Have a pause of this if you like and have a bit of a go, and if not, I'm going to work through this for you. So let's look at the question. Magnesium and oxygen react to form magnesium oxide according to the equation here. 2 magnesium react with oxygen to make MgO, and there's 2 of the magnesium oxide. If 6 grams of magnesium, 6 grams, 2 grams of oxygen, 2 grams are available for the reaction, determine the limiting reactant, the reactant in excess, and by how many mole, and the mass of the magnesium oxide formed. And what I've done down here is I've broken down the question for you, because the first thing you need to figure out is what the question's asking. So part A is working out the limiting reactant, the reactant in excess, and by how many mole. Part B is asking you for the mass of magnesium oxide. Okay, so let's see where we'd go on this. Let's work out part A first. So we know that magnesium, M equals 6.00 grams, and oxygen, M equals 2.00 grams. I like to work directly beneath what's going on in your equation. You can always go back and see exactly what you're doing. We've got number of mole equals M on M, which equals 2 divided by 32, which equals 0.0625 mole. Okay, so we've just worked out how many mole we've actually got available. So of magnesium, we've got 0.247 mole, and of oxygen, we've got 0.0625 mole. What we need to work out now is which is the limiting reagent, because that's the one we're going to base the rest of our calculations on. So, mole ratio, 2 magnesium will react with 1:02. So that's our mole ratio. Now, let's solve for magnesium first. So if I've got 0.247 mole of magnesium, I'm going to require a half times 0.247 of oxygen, which is going to equal, I'll put it here, 0.1235 mole. Do I have 0.1235 mole of oxygen? If we look back here, I've only got 0.0625 mole, so I don't have enough of this, so this reaction cannot go ahead. Let's have a look at the reaction the other way around. So I've got 0.0625 oxygen. I'm going to need mole ratio times 0.0625 of magnesium. 2 times that is 0.125 magnesium. Do I have 0.125 magnesium? I look back up. Yes, I do. I've got more than enough. So we can see here that oxygen is the limiting reactant. And that is how many moles of oxygen. So the reactant that's in excess is the magnesium. So magnesium is magnesium is in excess by how many mole? Well, we've got 0.247 mole, and we're only using 0.125 mole. So, excess equals 0.247, we started with, minus 0.125, which equals 0. Of magnesium is in excess. Okay, so we've just worked out the limiting reactant, the reactant in excess, and by how many mole the reactant's in excess. Often the question will ask you how many grams are left in excess. And to work that out, now that we know the number of moles, all we would need to do is use the molar mass to find out the mass. So let's have a look at part B of the question. The important thing that we need to work with now is that we need to remember it's this limiting number of mole here that we need to use, because that's how many mole are used in the reaction. So, using that limiting reactant mole, we have number of mole equals 0.0625 of oxygen. Number of mole of, we're trying to work out what the mass here, mass equals question mark. So just so that we remember what we're trying to work out. So we know that 1 O2 will react with 2 MgO, or react to produce 2 magnesium oxide. So if I've got 0.0625 O2, it is going to produce mole ratio times 0.0625 of magnesium oxide, which will equal 0.125 MgO. Does it make sense? 1 is half of 2, 0.625 is half of 0.125. So that bit makes sense. Now we know the number of mole. Number of mole of MgO equals 0.125. The molar mass, I should say, of MgO equals 40.3. So we can solve for the mass now. Mass equals number of mole times big M, which equals 0.125 times 40.3, which equals 5.04 grams. And that is 3 significant figures as per the question. Okay, have a go at question 12. I'm going to do another work solution here because I think the more that you see the better, but if you're feeling confident, give it a go. The answers are in the back of the booklet. See what you get. Otherwise, watch this one as well. So what mass of barium sulfate precipitates when 50 ml of 0.5 molar barium chloride solution is mixed with 25 ml of 0.90 molar iron sulfate solution? First thing you need to do, as with any stoichiometry equation or reaction, is write down the reaction. So I've got barium chloride is mixed with iron sulfate solution. What's it forming? What mass of barium sulfate precipitates? That gives me my first barium sulfate, and it's a solid because it's precipitating, so all we're looking at the other product, which are the other 2 ions, which will be aqueous, and they are iron and chloride, which there'll be 2 of those, and that is aqueous. So let's write the information that we know. So barium chloride, it's telling you that 50 ml of a 0.05 molar. So V equals, it has to be in litres, so 0.05 litres, concentration equals 0.050 mole. What else do we know? We know that it's mixed with 25 ml of 0.09 molar iron sulfate. V equals 0.0250 litres and concentration equals 0.090 molar. What are we trying to find out? The mass of barium sulfate. M equals question mark. You might start seeing now why I write what I'm looking for, because you can do 5, 6, 7 calculations and get yourself a little bit lost. You write this at the top, you can always just go back and check, did I find out the mass? Did I find out the number of mole? What was I looking for? Okay, so now that we know these, we can work out the number of moles. So number of mole equals C times V, which equals 0.05 times 0.05, which equals 2.5 by 10 to the negative 3 mole. N equals C times V, which equals 0.025 times 0.09, which equals 2.25 by 10 to the negative 3. Barium chloride and iron sulfate react in a 1-to-1 ratio. So this is quite an easy question, because we need 1 mole of barium chloride will react with 1 mole of iron sulfate. So if I have 2.5 times 10 to the negative 3 moles of barium chloride, they will react with 2.5 by 10 to the negative 3 iron sulfate. We don't have that much iron sulfate, and I'll write that out just in case you're a little bit confused. So 1 mole of BaCl2, 1 of FeSO4. So if I've got 2.5 by 10 to the negative 3 BaCl2, it needs to react with 2.5 by 10 to the negative 3 FeSO4. I don't have that much, so this reaction cannot happen. However, if I do it the other way around, 2.25 by 10 to the negative 3 FeSO4 can quite easily react with 2.25 by 10 to the negative 3 barium chloride. The reason being, I've got more barium chloride available. So it is in excess, it's not asking me this, but it's in excess by 2.5 by 10 to the negative 3 minus 2.25 by 10 to the negative 3. So barium chloride is in excess, and this is the limiting reagent. And this is the quantity that you need to use for the next bit of your calculation. So the next bit we're working out is how much mass of this. So we need to use this amount of mole. So let's look at our mole ratio. We've got 1 FeSO4 reacts with 1 BaSO4. Therefore, 2.25 by 10 to the negative 3 FeSO4 must react with 1 times 2.25 by 10 to the negative 3 barium chloride. So N of barium sulfate equals 2.25 by 10 to the negative 3. Big M equals 233.4 grams per mole, which I just know from the periodic table. So the mass equals N times M, which equals 2.25 by 10 to the negative 3 times 233.4, which equals 0.525 grams. And that's our final answer. I always like at this stage to go back up, and mass, that's what I'm looking for. I've got my final answer. Okay, hopefully that all makes sense. You can now continue with those booklet questions. I'd really like you to do questions 13 and 14 if you haven't done, or if you haven't done them, well, you can do them now. And then chapter 15, there's some more questions there for you to go on with, so 34 to 39. Let me know if you've got any questions.